So why do we care about this formula? It's because of a theorem that says that geometrically, the determinant of the three vectors A, B, C is, again, plus or minus. This determinant could be positive or negative. See, there's minuses and there's all sorts of stuff. Plus or minus the volume of the parallelepiped that's just a fancy name for a box with parallelogram sides, in case you wonder. With sides A, B, and C. Okay, so you take your three vectors A, B, and C, and you form a box whose sides are all parallelograms. And then its volume is going to be the determinant. Okay, so let me move on to cross product. So cross product is something that you can apply to two vectors in space. And by that I mean really in three-dimensional space, okay? This is something that's specific to three dimensions. So the definition, A cross B, so it's important to really do your multiplication symbol well so that you don't mistake it with a dot product. Well, that's going to be a vector okay, so that's another reason not to confuse it with dot product. Dot product gives you a number, cross product gives you a vector. So they're really completely different operations. They're both called product because, well, somehow one couldn't come up with a better name, but they're completely different operations. Okay, so what do we do to do the cross product of A and B? Well, we do something very strange. Just after I've told you that a determinant is something where we put numbers and we get a number, I'm going to violate my own rule. I'm going to put together a determinant in which, well, the last two rows are the components of the vectors A and B, but the first row, strangely, consists of the unit vectors I, j, k. What does that mean? Well, that certainly is not a determinant in the usual sense. You cannot, if you try to put that into your calculator, it will tell you there's an error. I don't know how to put vectors in there. I want numbers. What it means is it's a symbolic notation that helps you remember what the formula is. So the actual formula is, well, you use this definition, and if you use this definition, you see that it's I hat times some number. Okay, so let me write it as determinant of A2, A3, B2, B3 times I hat minus determinant A1, A3, B1, B3, J hat plus A1, A2, B1, B2, K hat. Okay? And so that's the actual definition in a way that makes complete sense. But to remember this formula without too much trouble, it's much easier to think about it in these terms here. Okay, so that's a definition. And it gives you a vector. Now, as usual with definitions, the question is, what is it good for? What is the geometric meaning of this very strange operation? Why do we bother to do that?